Section 6.3 continues our properties on parallelograms, talking about how do we know if it's a parallelogram, how can we prove it. So let's take a look again. Here's a picture. Let's make this a little bigger because we'll just draw on the picture. Different properties of a parallelogram. You got to have these memorized. Opposite sides are parallel. So let's draw the arrows. Along with opposite sides being parallel, opposite sides are congruent. Along with that, opposite angles are congruent. And then we had diagonals bisect each other. And then we also had a property that consecutive angles or same side interior angles were, that's an R not a P, angle L plus angle P equals 180. The supplementary angles are the angles that are right next to each other. So those are the 5 properties that we have to have memorized. Now, when we go to prove that a quadrilateral is a parallelogram, we're going to be given a quadrilateral, and based on what's given in the picture, we have to determine yes or no. So you can show one of those 5 properties that I just had on this picture here, or there's a new one. I could show that one pair of sides is parallel and congruent, and you'll see an example of that on the next slide. So, determine if these are parallel, or if they're a parallelogram. So, first one, opposite angles, opposite angles. Yes, because if parallelogram, then opposite angles congruent. This one, I only know one pair of opposite sides are congruent, so I'm going to say no. Whereas down here I know both. This one's yes, because if parallelogram, then opposite sides congruent. And this last one is that new theorem that I just pointed out over here. One pair of sides is parallel and congruent, because if parallelogram, then opposite are congruent and parallel. So we want to find x and y so that it makes it a parallelogram. Well, for it to make it a parallelogram, we know these sides have to be congruent. We know these sides have to be congruent. So we know x plus 20 equals 3x minus 14. And we know 3y plus 2 equals y plus 20. So when we go through and we solve, 2x equals 34, x is 17, subtract the y, and y equals 9. So the solving the equations part is nothing new. It's stuff that you can do. The new part is you have to remember to set opposite sides equal to each other. So now we're going to be seeing this chart throughout the entire unit. And as we go through the unit, we're actually going to build on this. We're not actually going to use these bottom 2 rows until section 6.4 and 6.5. But for right now, what we want to do is, based on these points, can I prove that the shape is a parallelogram? So what we're going to do is we're going to take those points, 0, 0, 3, 4. I apologize for picking the smallest graph possible. 7, 4, and 4, 0. So when we draw that, it looks like a parallelogram, but you can't just say, yes, it looks like it, so it is. What we actually have to do, because we know that if opposite sides are parallel, that means that they're congruent, that the opposite sides are parallel, meaning that it is a parallelogram. So I'm going to find the slope of each side. These 2 horizontal sides, slope is 0. And then on this one I go, remember, rise over run, up 4 and over 3. And over here, up 4 over 1, 2, 3. Because 0 is the same as 0, 4/3 is the same as 4/3, it's parallel, meaning it's a parallelogram. If they weren't parallel, you would write not a parallelogram. So we've got 4 problems that we're going to do. Check your answers first, or try it, then we'll check our answers. Determine if it's quadrilateral. If so, opposite angles are congruent here and here. Opposite angles are congruent here and here, which means since opposite angles are congruent, yes, it is a parallelogram, because if parallelogram, then opposite angles congruent. Next one, I know this side's parallel. I know these are congruent. If these congruent marks were over here and here, then I could say yes. But since they're not, I have to say no. I don't know if that's a parallelogram. We have this diagonal bisected, this diagonal bisected. So yes, if parallelogram, then diagonals, bisect. And the last one is another graph. Let's go ahead and plot these points. Uh, 5, 3, and 4, 0. So there's our points. And our slopes, top and bottom are 0 again because it's a horizontal line. Over here we go up 1, 2, 3 over 1. 3 over 1 is 3. And over here we go up 3 over 1, which is 3. 0 is the same as 0. 3 is the same as 3. So it is a parallelogram. And we're not going to worry about these two sides, or these two steps just yet.